Firefighters have been doing their jobs heroically for centuries. Their uniforms, however, were not always up to the task. Today's firefighters, though, are cloaked in layers of space-age material. The protective armour has virtually eliminated firefighter deaths caused by burn injuries. A computer-guided machine cuts out more than 90 parts to make the outer shell, just one of 3 layers that make up these firefighter jackets. This fabric contains a synthetic fibre known as PBI, which can protect against temperatures higher than 600 degrees Celsius. Another machine tapes the seams of the jacket's middle layer, the moisture barrier. Pressure rollers and heat activate glue in the tape, sealing the seams. This synthetic fabric lets perspiration through, but blocks some harmful liquids such as battery acid, hydraulic fluid, or infected blood. Now the moisture barrier is lined with the thermal liner, the jacket's third and innermost layer. This synthetic fabric protects against temperatures of over 400 degrees Celsius. To reinforce them, the cuffs, hems and front and back panels are sewn together with heat-resistant tape and thread. But the neck area is left unattached, so the firefighter can pull the jacket inside out to inspect the liner between rescues. Back to the outer shell. 2 orange and silver stripes are sewn to the front and back panels. A stripe is also sewn onto each sleeve. The fluorescent orange makes the firefighter more visible in daylight. The reflective silver is for nighttime or in smoky conditions. In some cases, reflective die-cut letters are added, identifying the fire department or spelling the firefighter's name. A strip of Velcro goes onto the left front panel. It's one of 4 ways to fasten the jacket, in addition to zips, poppers and hooks. To keep water from entering through the front of the jacket, a strip of the same fabric used to make the moisture barrier is attached. It's sewn inside the outer shell's right front panel, known as the storm flap. The storm flap's other side gets a Velcro strip that mates with the Velcro on the left panel. The front panels are attached to the back panels. The garment is folded over and the machine sews through the 2 layers at once. It's another way to reinforce the seams of the jacket. A different sewing machine is used to attach the sleeves. 5 different seams are sewn to join the shoulder areas. This is critical because the firefighters will be carrying an 11-kilogram air tank on their backs. The seams spread out the stress this weight places on the jacket. 3 metal poppers are attached to the inside front of the outer shell. These will attach the outer shell to the 2 inner layers. Then, a heat-resistant plastic zip is added. This machine applies 3 rivets to each of 4 spring-loaded hooks along the right front panel of the jacket. A 1.8 metre long strap cinches around the armpits to drag an injured firefighter away from danger. The assembled inner layers are snapped together with the outer shell. There are 4 poppers on each cuff, which could heat up quickly in a fire. Tabs ensure they never burn the firefighter's skin. The front panels come together with 4 poppers on each side. The 10cm collar unfolds, covering the neck where it meets the firefighter's helmet. This testing device gauges how long it would take to sustain a 2nd-degree burn. A gas burner shoots a flame that's over 1000 degrees Celsius directly onto the jacket's outer layer. A sensor mimics human skin sensitivity to heat. The material fails the test if the transferred heat would cause 2nd-degree burns in less than 17.5 seconds. Finally, the uniform is showered for 20 minutes to test its watertight seal. The dummy is wearing a cotton bodysuit underneath. Just one wet spot on that bodysuit and the uniform fails inspection.